All right, let's fill in this chart here talking about the relationship between the confidence level and the significance level for a hypothesis test. So if we have a confidence level, so talking about confidence intervals, if we have a confidence level of 90% and we have an alternative hypothesis that is two-sided, then that corresponds to a significance level of 10%. Okay, so that corresponds to a significance level of 10%. If we have a confidence level of 95%, and it's a two-sided hypothesis test, that corresponds to a significance level of 5%. And then if we have a confidence level of 99%, and it's a two-sided test, that corresponds to a significance level of 1%. I should have included that row in this chart. I'm not sure why it's there. But that's the correspondence there between a hypothesis test, a two-sided hypothesis test, and a confidence interval. So let's look at an example. It says in 2009, it was estimated that 63% of, I think we actually had this example in the last video, so I may sort of go through this a little bit quicker here because we had this example in section 8.2. So take a look at your notes for section 8.2 so you have all the numbers in front of you. 63% of Americans supported the death penalty. In 2014, a Rasmussen poll found that in a sample of 943, only 538 supported the death penalty. Actually, I think the number is a little bit different than what I had in the previous example. Do we have evidence that supports if the death penalty has changed? Okay, read the question carefully. It's actually a little bit different from the one from the previous section because they want to know if the death penalty has changed. So let's go ahead and run through it. So our hypothesis, our null hypothesis, is that P is still 63%. Our alternative hypothesis is that P does not equal 63% because it says now has changed. So now this is a two-sided hypothesis test. I'm going to skip the prepare test. We certainly know that this sample is large enough and it was done randomly. So let's go to StatCrunch and let's get the information that we need. So notice this is 538 out of 943. So let's go to StatCrunch. Remember, we go to Stat, Proportion, One Sample with Summary. So 538 out of 943. And so my null hypothesis is that P is 63%. My alternative is that P does not equal 63%. And I'm going to click on Compute. All right, so let's record this information. We had 538 out of 943. And the sample proportion that goes with that is right here, the 57%. So let's put that down here, 0.57. And then the standard error that goes with that is right here, 0.0157, so 0.0157. The z-score that goes with that is negative 3.78. And then the corresponding p-value is 0.0002. All right, so what does that mean? So if the p-value is small, they said to use a 5% significance level, but it doesn't really matter because this is going to be smaller than any significance level we would ever consider. So our p-value is very small. So p-value is small, and so that means that we reject the null hypothesis. How can we phrase this? There is evidence that support for the death penalty has changed. Now notice I didn't say declined, I said has changed because that's what my alternative hypothesis was that P was not equal to 63%. So right now that's all I know is that it doesn't include 63%. Could be higher, could be lower. Actually, it's going to be lower, but we'll talk about that in a second. But we know that it has changed. That's the only thing we know right now. All right, construct a 95% confidence interval for the actual proportion of Americans. So now we want to know what is the proportion of Americans. So the question now is what is the proportion of Americans who support the death penalty? Now that is the question. So I'm going to go back to StatCrunch. And what's nice about this, the way it computes these, is we can keep the data in here and go to Options, Edit. Don't change any of the data, but come down here and click on Confidence Interval, right? We wanted a 95% confidence interval. That's what they're asking us. And here it is. So let's fill in the information. Our counts are the same. It's going to be 538 again out of 943. And so the sample proportion is still 57%. The standard error is 0.0157. Now, the lower limit is right here, negative 0.54. I'm just going to round it. I'm sorry, I don't know why I said negative. I was thinking about my z-score up here. 0.54. We're not going to have a negative lower limit. That doesn't make sense. And then my upper limit is right here, 0.60, somewhere in there. So what does that mean? We are 95% confident that the proportion of all Americans who support the death penalty is between 54% and 60%. So does this support our conclusion from earlier? Yes, because notice what is not, notice what is not in this interval is the 63% that we were interested in, right? The 63% was what we were comparing with originally. Notice that 63% is not contained in this interval. So how does this support our conclusion of our hypothesis test? This supports the hypothesis test conclusion because the 63% is not contained in the confidence interval. In other words, the population proportion has changed. And the confidence interval gives us a little bit more information. It tells us that it's actually declined. Now it's lower, but the main thing is that it did not capture that 63%, and that's what we were interested in comparing it to. So whatever you get, when you do your project, that's something to remember. Whatever you get for your hypothesis test results, it better support whatever you got for your confidence interval and vice versa. Those two things should be complementary. They should go hand in hand. They should support each other, okay? All right, so let's take a look at the next example. An education researcher decided to run a test of hypothesis to test the claim that the majority of all college students visit their Snapchat account daily based on the data of one college. The test results were as follows. So here's the null, here's the alternative. This is a majority test, so this should look like what you'd expect from a majority test. It looks like he surveyed, or she surveyed 75 people, found that 41% answered yes to this question. The test statistic is here, and the p-value is here. So what would you say about that p-value? Well, that p-value is pretty high. That p-value is almost 21%. So conclusion, we could say there is a 21% chance of getting a sample of college students where 50% or more of the students visit their Snapchat account daily. No, I'm sorry. Wait a minute. That's the wrong number. Hang on one second. Let me fix that. Let's read this again. So your p-value is the probability of getting your particular sample or something more extreme. Your particular sample was right here. This was your particular sample. So it's the probability of getting a sample where 55%, right? That's your p-hat value, or more. And why is it or more? It's or more because of the way the alternative hypothesis is phrased. It's greater than, where 55% or more of the students visit their Snapchat account daily if the null hypothesis is true. So if the true percentage of all students who visit their Snapchat account daily is actually 50%, because that was our null hypothesis. Based on that p-value, would you reject or fail to reject the null hypothesis? Well, we're going to say fail to reject H naught. Why? Because the p-value is large. Again, they didn't give us a significance level, but it doesn't matter. 21% is going to be larger than any significance level we would want. So how do we conclude this? If we fail to reject the null hypothesis, what does that mean? We do not have evidence to support that a majority, right, the alternative hypothesis. We don't have evidence in support of the alternative hypothesis that a majority of all college students check their Snapchat, I think it was daily, right? Check Snapchat daily. So we don't have enough evidence in support of the alternative. We think the null hypothesis is probably still true. We don't know for sure, but we think it's probably still true. We don't have enough evidence to support the alternative. Last question. In in past years, suppose that it was believed that roughly 49% of Americans had visited a library. Suppose the American Library Association wishes to know whether attendance is declining. They examined a survey conducted in 2013 in which only 48% of those in a random sample had attended a library in the last year. We need to get some updated data. It's only from 2013. We should be using something a little more recent, but that's all right. We'll go with it. The librarians decide to use a strict significance level of 1%. They carry out a hypothesis test with the results shown below. Based on this, they send out a press release that says, we have proved, oh, that's a strong word, we have proved that there is no decline in library attendance. What mistakes did this association make? All right, so first of all, let's look at their results. Is their hypothesis correct? The null hypothesis is that P is still 49%. They wanted to look at whether attendance has declined, so the alternative is that P is less than 49%. That looks good to me. They put in their data here. They got their sample proportion here. Their z-score is here. Their p-value is here. Okay, so a couple of things to note. The p-value, they used a significance level of 1%. The p-value is 0.057. Even at a 5% level, that is not significant, right? That is not smaller than the alpha level. So the p-value is actually larger than the alpha level. So what does that mean? That means that we would fail to reject the null hypothesis. That means we think the population proportion, we have evidence to support that the population proportion is still at 49%. But did you notice I said there's a really strong word they've used here in their conclusions? We never, ever, 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 listen, remember this, we never use the word prove. We're not proving anything, okay? So we never say prove. Never say prove or accept, that's another one you don't want to say, or anything like that. We never use those terms when we're describing hypothesis tests. So the mistake that they made is they used the word prove. We don't want to say that. What could they have said instead? They could have said, we do not have evidence to support the alternative, which is that the attendance is declining. So we do not have evidence to support that attendance, or whatever it was, attendance at the library. Attendance is declining. So we can say, based on this survey, we don't have evidence that the attendance has declined below that 49% number. And that's really all we can say there, is that we just don't have evidence to support that the attendance is actually declining.